Welcome to the how-to for ionic bonding. Ionic bonds are between a metal and a non-metal, an anion and a cation, or some kind of polyatomic anion. And in this case, we could think about something like sodium chloride in a simple combination reaction, where sodium is reacting with chlorine gas and forming sodium chloride salt. Sodium chloride is the ionic compound. So when we think about why this occurs, really we think about sodium. Sodium is going to have a very, very low ionization energy for its first ionization energy because it really wants to give up an electron, right? It's in that group 1A. If it gives up one electron, it would satisfy its octet rule. Chlorine, on the other hand, has one too little electrons. It really, really wants one more. And so it has a very negative electron affinity, saying that it really, really wants to gain an electron. Well, these two react really nicely together because sodium is going to want to give up an electron, while chlorine is actually going to want to accept that electron. And what happens is as sodium loses an electron, it becomes a sodium ion because now it only has 10 electrons and 11 protons, whereas chlorine, which picked up this electron from sodium, now is going to have 17 protons but 18 electrons. We have a positive charge and a negative charge which are attracted together. This forms what we call a lattice. And understanding this is, let's imagine that you're really, really tiny and you're buried inside this lattice energy, or inside this lattice. How much energy is it going to take to pull all these apart, to separate them completely? That is what we call the length of a lattice. Really comes down to an equation. The lattice energy is just the energy required to completely separate a mole of a solid ionic compound into its gaseous ions. The way I like to think about it is energy. And it's really dependent on two things. So when we think of lattice energy, which this could be abbreviated L dot E dot, we have some kind of constant times the charge of one of the atoms times the charge of the other atom or ion divided by some distance. What distance between the ions? How big are these ions? And so you can kind of just remember this rule that lattice energy is going to increase with the charge on the ions and increase with decreasing size of the ions. What do I mean by that? Again, the greater the charge on the ions, the greater the lattice energy. As it increases, okay, they're going to actually decrease the lattice energy. It's easier to pull them apart. They're separated farther. Or you could think about it as the lattice energy is going to increase with decreasing size of the ions. Well, let's just start off by talking about a very simple ionic compound, where one ion has a +1 charge and the other is -1. These are very small ions. Well, they're going to be attracted to one another. But let's say that the charge increased. Instead of +1, what if it was +100? Instead of -1, what if it was -100? Well, these are going to be more and more attracted together because of as much stronger the charge. But we could also think about larger atoms or ions. And in this case, we have +1 and -1. But you can see that these are much larger than they were over here. Well, that really means the distance has increased between the two nuclei. And as so the smaller they are, the closer they get together, the more they're attracted to one another. Again, the same thing when we compare this ionic compound to this ionic compound. Here, the distance is much, much greater than here. So the lattice energy here is going to be much greater. That concludes the how-to for ionic bonding.